Good everyone. May I have your attention, please? We are from Arup. It's an engineering consultancy company. I'm Gaurav Kumar, and with me is my colleague Hanyu. We are from Climate and Sustainability Services team. I'm from Singapore team, and my colleague Hanyu is from Malaysia team. In this session today, I'll be going through a few very important and very basic things on carbon emissions and then calculating your carbon footprint. So we try to cover a broad topic because carbon emission and carbon footprint varies from organizations to organizations. So be it if you are in the construction, the carbon footprint and emissions will be completely different from an organization who is more into production of goods, food, and things. So we try to capture a few of those in our slides. So if you are all ready, we can start. Next slide. So this is the agenda we are going to cover today. First, I wanted to have an understanding of how you perceive as a GHG emission. It's a very commonly used topic and the words. And then we will move on to decarbonization. Wait, please. And then what are the drivers? Why suddenly everyone is talking about decarbonization and emissions? And how to decarbonize? It's one of the most important challenge we have as an industry. And once you know how to decarbonize, you should know how much emissions you as an organization or as a company are creating. And then at last we'll touch upon few points on how to reduce your emissions. What are the ways you could consider to reduce your emissions? Next, please. Yeah, so everywhere wherever you go nowadays, everyone is talking about carbon, right? It's everywhere. We are made of carbon, and now we have our enemy, which is carbon. So everyone is fighting. So I'll just put, we try to be engaging. I'll put questions. If you have answers, you can just raise your hand, shout the answer. So we'll just see what are emissions. Anyone know what is GHG emissions? You probably have heard, you know the answer. It's okay, we can have it engaging session rather than I'll talking for the whole 45 minutes. Anyone? Yes, correct. Absolutely correct. You're right. So next. So basically GHG emissions are with gases in the Earth atmosphere and that traps heat, and because of that our planet is getting heated up, and that's the problem. So there are mainly 7 greenhouse gases, but the main focus is on this last 3 which is mentioned below is carbon dioxide, methane and nitrous oxide. For simplicity, we have chosen carbon dioxide and everything is kind of converted into that carbon dioxide. So if you see a term called carbon dioxide CO2 equivalent, that means that it could be another gas or another GHG, but that is converted into a CO2, so to kind of have a standardized definition or standardized values. Next. So there are mainly 4 gases I'll talk about, and then we can see how they are created. So mainly carbon dioxide is very simple. Whenever you burn something, the result at the end product is CO2. Whereas methane is mainly emitted through production of coal or natural gas and also from livestock. So livestock is one of the main creators of methane. Nitrous oxide is mainly from industrial and agricultural usage, and fluorinated gases is again from industrial. Most common is used in air conditioning and fire retardants. Next. So if you see the carbon emissions in the whole built environment, the main cause is coming from industries because they are producing a lot of products and materials. And if you combine buildings, which is building operation, and building operation is mainly coming from your electricity consumptions. We are using lights, air conditioning, we are running our computers, devices, and that is causing energy. And that has a huge emission impact, around 28%. And another contribution from building is coming from material and construction. So we use bricks, cement, concrete, steel, rebars, and then heavy machinery, transportation, everything that is used to construct a building is 11%. And then other are around 23% for transportation and 6% for other usage. Next. So now, when we see greenhouse gases, right, there are different scopes. And why there are different scopes? Because the result is not one source. So these are coming from different sources, and that's why they are scoped into different categories. Scope 1 is very direct, whatever you are burning on your site, on your control, on your organization. For example, if you have a company and you have 10 cars, and these cars, 10 cars or trucks or any transportation, you are burning petrol, diesel, that's your direct emission because you are responsible for that burning. So that's scope 1. Scope 2 is indirect, which means you are creating that demand, and to create that demand, someone else is burning for you. For example, you are running 10 buildings, and those buildings are using energy, electricity to operate. In order to operate those 10 buildings, you are putting pressure, or you are requesting the the electricity supplier to provide you that much energy, and then the electricity supplier is burning natural gas or other coal, or even sometimes different means to generate those emissions. So those emissions are into scope 2. Okay, whatever is not in scope 1 and 2 is simply put in scope 3, which is again indirect, but these are not in your controls. For example, your commute, you are traveling for your work, and you are sitting in an aeroplane or taxi or vehicles, and that is having emission, so that's considered as scope 3. You are, for example, you are purchasing some products, you are purchasing computers, you are purchasing chairs, that is scope 3 because you are creating that demand and there are emissions to meet those demands. Next. So yeah, if you again a simple translation of scope 1 and 2 and 3. So in general, scope 1 and 2 are more in our control. We as an organization can control scope 1 and 2. For example, we can control our fleet, we can control our energy consumption, we can monitor it, we can reduce it, and even we can have some solutions on site to further reduce it, cut it down. Whereas scope 3 are a majority of other factors, it's not under our direct control, but that's where the whole world and whole governments and international organizations are trying to fix this, that most of these emissions can be controlled, and it can be at least calculated and reported in a way that later you have a chance to control that. Next. Okay, question time again. So, which scope of emissions are associated with buildings? Can anyone make a guess or know the answer? Then you can just say it loud. You can just say it, don't be shy. It's okay, we are all. Scope 2, yes, correct. Anyone else? And ma'am, why is it scope 2? Absolutely correct, yes. Any other scope? Okay, it is scope 3 as well because you are using building products like concrete, glass, aluminum, and you are sourcing from an external party, and in order to create that concrete and steel, that company has to burn a lot of fuel, and there is an emission cost from that. And that is also called embodied carbon. And you may have heard this term, so it's also associated with building products. It's mainly used in the construction of the buildings before the building even starts operation. Second question, which is the predominant scope for a chocolate company? Let's say there's a chocolate manufacturer. So what is his main scope? So I'm just talking about what is the maximum contributor of his emissions in terms of percentage. And it's almost around 80 to 90%, even sometimes more than that. Any guesses? Wild guess? There are just 3 answers, either scope 1, 2, or 3. Okay, we'll see that in later sections. Okay, it's just one more question. There is an increase. So, okay, you as an organization, you started to reduce your fleet and emissions from your fleet, and then you purchase a lot of electric vehicles. Definitely, you are reducing your one type of scope, but it will also add your dash emissions. Which emissions? Correct, yeah, scope 2, because your electricity demand will increase from EVs, although it will be lesser than your diesel and petrol. Next slide. Okay, yes, we have a conflict of answers. That's good. Yeah, so that's scope 3 because you are not controlling that, and you are also so yes, you are right. You are sourcing it from different suppliers, and they are using that energy to source it. So it's indirect. It's not in your control. So that's why it falls under scope 3. I'll have an example of that company later.
Can I ask the part one, the number one? If you build a building, you say it's a material is scope 3, right?
Yes.
Because what if we purchase that building? Do we calculate the scope 3 when we purchase a building?
No, it's actually a very good question because when you purchase the building, it's already been constructed, and then it has operated like maybe for a few years, and then you purchase. So your contribution was not in purchasing that building. So then it will be predominantly scope 2. There will be scope 3 when you, after certain years, 5 or 10 years, you are going to repair that building or maintain that building. And in order to do that, you will be, let's say, doing a false ceiling or flooring. Then you will have add on to scope 3, but that percentage will be lesser. I have a section on that as well. Next, please.
Sorry, I have a question.
Oh, sorry, yes.
I just wanted to the slide earlier about you mentioned commute, right? Employees commute.
Yes.
So that would fall under
Scope 3.
scope 3, okay. But what about when a company sends its employers for business trips, like they put them on a plane? Because the difference between scope 2 and scope 3, by the definitions that you provided, seems to be the test, right? Whether, the test is the control, right? Whether there's a control or not.
Yep.
So does putting employees on a plane for business trips, official trips, is that considered as scope 2 then? Or is it still scope 3?
It's still scope 3. Yeah. So scope 3 is because if you are sending an employee for some work, you are using a third party vehicle, which is an airline, and that emission is caused by that airline. So you are still indirectly responsible for that emission. Whereas scope 2 is predominantly focusing on energy. So you can simply put in that way is scope 2 is mainly energy. Scope 3 is the rest of that. So if you see most of these organizations, they are making commitments in scope 1 and 2 that I want to go net zero by 2030, 2050 for scope 1 and 2 because it's much easier to control. You can control your own building operation, but things like employees commute, purchasing products and goods, it's something you need it. And it's a bit hard to control, and it's also a bit, you have to fix your boundaries. Yeah, so just what I was talking, I have 3 examples here. First is on operations, which can be considered as a chocolate factory. You have scope 3 emissions, which contributes most because you are dealing in sourcing and supply chain and transportation. Whereas scope 1 and 2 is your on-site, could be coming from your factory. You are using fossil fuel on-site to maybe compressors or equipment which is running on diesel or petrol. Plus, you are also using energy to operate your factory or your offices. So that's why you can see the percentage varies. Whereas what you have asked, sir, is existing assets. So you can see that the percentage distribution changes because your maximum contribution is coming from scope 1 and 2, which is your on-site energy consumption and diesel consumption. Whereas scope 3 is very less because you already have purchased an asset. So that asset does not require additional steel, concrete. It still requires some little maintenance like facade changing or flooring or those maintenance which is cyclic. If you think of new assets, everything is scope 3 because you are starting from scratch, and all those building materials, construction, transportation, everything is coming from a indirect source. So for new construction, before the building has even started, until the point of, you can say, the TOP date, is all scope 3. Once you start using that building, then you can see that scope 2 will keep on adding, and then it will fall into that existing category when the building is 10 years, 20, 30 years old. And there are ways you can reduce that emission. You can first, definitely you can reduce by optimizing your design and construction and production, optimizing your business operations. And then there are ways you can further reduce it by renewables and offsetting your production, carbon offsets. Next. Yeah, so again, I think I already spoke about this. For a building, you can see that scope 1 plus 2, which is predominantly coming from energy, is about 70%, and scope 3 is around 30%. And then you can see the breakdown of scope 3. So this is a project we have worked on. Is you can see the scope 3, which is your building materials, and it's an example of a new building, a study done for a 60 years of life. So if the lifetime is lesser, your emissions will be lesser, but the percentage distribution may change. So yeah, you can see that the emissions is coming from the structures, facade, space plan, which is an interior partition, glass, everything, and then the site emission, which is used for your constructions, like all this heavy machinery used for construction. Next. So this is an example of a big company called Nestle, and you can see that around 90% of their emissions is scope 3. It's all coming from sourcing of ingredients, manufacturing of their products, packaging, managing the logistics, and also travel of their employees and commuting of their employees for works. So scope 3 is big. It has a lot of direct and indirect impacts, and my colleague will later cover into next sections that how it can be estimated and it can be reduced further. Next. So now we spoke a lot about carbon emissions and how it happens and where it happens and in what form it happens. So what is decarbonization? Easy, right? It's very easy. The answer is in the definition itself. Yes, please. Yep. So next, please. So decarbonization is basically whatever is causing emissions, you just reduce it, curb it, or at least control it, and then there are ways you can manage it. Next. So why there is sudden surge for decarbonizations? Next. So the first and foremost is we all can see that climate change is now visible. So we used to talk about climate change few years back, maybe decades back. Now we can see the impact of it. The temperatures are increasing. There is no regular precipitation. So sometimes there is a lot of rain, sometimes there is no rain. So you can see that even recently there was flood in Malaysia. So there is no pattern for the weather, and sea level is also rising, which will affect all the coastal areas. Plus, there is a huge, you can see in recent years, there is a huge increment in investment in sustainable, and that's called ESG investment. So a lot of investors are focusing on how sustainably you are managing your business and how sustainable your organization is, how much focus you are putting on sustainability in your businesses, and the investment is directly, you can see now it's exponential in that aspects. Banks, governments, everyone is pushing for it, which leads to the third part is climate disclosure frameworks. Most of the governments have started setting out frameworks for organizations which are in line with global reporting standards such as TCFD, and so that their main market is aligned. So currently the focus is for the big companies, but soon it will be coming to all the SMEs and local companies as well. Next. So the main key driver for decarbonization are two. You can say is first is the market pull. The market is pulling the whole discussion. If your operations are sustainable, you will get more incentive in terms of investment. There is a reputational risk. People are talking about it. If you are not running your operations, there is definitely financial risk because you will spend more, and there is also a reputation that you are not sustainable business. And then there is a legislative push from governments all around the world. Sometimes it's derived by the local government decisions. For example, Malaysia's target for net zero emissions by 2050. and also their Bursa Malaysia requirements for TCFD aligned disclosures. And sometimes it's also governed by international laws, for example, carbon border adjustment mechanism by European nations. Next slide. So these are a few guidelines and framework. There are so many guidelines. Why? Because each guidelines caters to a different set of businesses and organizations. And most of the governments are trying to align their disclosures with these guidelines. Next, which you can see as a summary here is a Singapore, Malaysia, Australia. So you can see the GRI standard, which is most commonly used, SASB, FTSE for good, TCFD, IFRS, CDP, and CDSP. So they are all reporting and disclosure standards for organizations of different scale and different businesses. Next. So a few examples of decarbonization key drivers. So earlier I mentioned about the cross-border carbon mechanism from Europe, and it is estimated that around 6.7% of Malaysia's export will be affected if the businesses are not sustainable aligned. For example, we can talk about one of the biggest contributor of carbon, but also one of the most important material for construction is cement. And there is a example of Siam Cement, which is planning to reduce its carbon emissions by 50%, which means that their emission, whichever is, you can say that concrete contribution in building construction is around 40 to 50%. That's a huge amount. And if they cut by 50%, that's still a huge amount of reduction in carbon emissions. So there is a push globally, and companies and organizations are adopting to it. Next. And you can see, you may have seen it in news and everywhere that every day more and more companies are aligned towards 100% commitment towards 100% renewable energy, net zero energy by 2050, or net zero carbon by 2050. And more companies are adding to the list. Next. So with many GLCs which have set a target for net zero by 2050, there is also an objective to identify carbon reduction, not just by GLC, but also by those companies who are SMEs and not huge. But soon it will be coming. It's crucial that SMEs can also identify their targets, their emissions, and then once you set your target, once you start calculating your emissions, definitely you will start seeing that which are the regions or areas I need to optimize and reduce. Next. So one of the example is from Singapore. So Enterprise Singapore, they have launched a new disclosure program with CDP, and the idea is just to bring the SMEs, because all those big multinational companies, they are aware about all these disclosure programs. They have their whole department for sustainability, but SMEs are kind of lagging behind. There is not much awareness. Everyone know about sustainability, decarbonization, but they don't know where to start, how to start. So it's a push by, and I think the same model will be applied in many Southeast Asian countries soon. Next. Yeah, so next question is how to decarbonize. So now we have seen what are emissions, what is decarbonization, why everyone is pushing for it. So it's not just environmental issue, but it's also what governments and agencies are pushing for it. So there are three solutions. First is definitely reduce your emissions. Second is remove emissions in form of plants or afforestation. And then third is offsets. So I will be covering more on this first, which is reduction, because second and third is you cannot do much about it unless you have huge land and you plan to plant big trees, or you spend some amount of money and then purchase offsets. So that's there, yes, but that should not be the first solution. The first solution should be how you reduce your on-site emissions. For example, you can replace all your fossil-based fuels or diesel gensets with electrical. They are more efficient and they have less emissions. Next. So this is a pathway we have done for a few of our clients, and we are implementing in few of our projects. Is kind of a stepped approach, in which first is what's your vision? Do you want to be net zero? Okay, that's fine. If it is too ambitious for an organization, at least set a vision that, okay, whatever I am doing, I should be 50% or 100% offset by in next 10 years or next 7 to 10 years. So that's the plan. You set a vision first, and then the very next step would be calculate your carbon footprint, because if you don't know where you are in terms of your carbon emissions, you will not know whether you will meet your target or not. Setting a goal is one, but knowing your condition, knowing your emissions is another thing. And that carbon footprint can include your operations, the way you operate your business. Your existing portfolios could be your offices, your leased offices, or your properties, and then your future developments, the new developments you are going to make in next 7 years. So all those should include your carbon footprint calculations, because your plan is for next 20, 30 years. Then you prioritize your actions. It could be in terms of intensity, carbon intensity, cost, and then capital value. And you can identify all the big risks, and you can start addressing those big risks first, because that will immediately reduce your carbon emissions. Manage your program, implement that organization wise, design and deliver all those interventions, and keep monitoring. Why? Because you want to test that your measure is successful or not. So it's very important to keep monitoring your interventions, your solutions. So the program structures could look something like that. You measure your impact, identify your hotspots, which are the maximum emitting resources or your works. Engage supply chain, implement scope 3 mitigations, and then redo it again. So it's an ongoing cycle. It's not something that you do it today and then you sit for another 10 or 15 years. It's an ongoing exercise, because you are emitting every day. Next. So again, we will focus on how do you measure your carbon. So the first thing is, I think you have heard this quote a lot. You can't manage what you can't measure. So if you don't measure, you will never manage your carbon. So the first is, how do you measure your carbon? And it's not that difficult. It's just that it's a bit fragmented. There are so many streams of businesses. Next. So my colleague will take on from here. How do you calculate emissions for an organization's point of view? And later we'll cover a few examples as well, like how we have done for few, we'll show some case studies.
Thank you, Gaurav. Yeah, I'll take on from here on how to calculate the emissions. I believe Gaurav has already provided good introductions on emissions, decarbonizations. So now we go into a bit more technical and hands-on. Next slide, please. Yeah. So under the Scope 3 accounting and reporting overview, under the GHG protocol, they've broken down this into steps, basically into 9 steps. And as Gaurav mentioned earlier, I mean, the first step is definitely on defining the business goal. You need to know your goals before setting out the steps to follow. Review accounting and reporting principles, we have 5. I will go into detail into this later on. Identifying the activities and set the boundary of your areas that you think is hotspots. The biggest emissions come from those areas. Collect data and allocate emissions. So allocate emissions is only important for those reporting that say you engage a supply chain and they produce more than one products. We'll go into this into detail again. So setting a target is also very important. That's the size of the target, the level of target, and by when. Then after that, we have assure emissions. Assurance is optional. You can have a first party and a third party one, which I will go into detail again later. And finally, it's on whether or not you report your emissions. Next, please. Yeah, as mentioned, define the business goals. We need to identify and understand the risks, opportunities associated to your company, and set out the opportunities, set the reduction targets, and also track the performance over time. Then this can also help us engage the value chain partners in greenhouse gas management, because it's a whole process and you need the whole value chain to come together to reduce the emissions. And this also can help your informs the stakeholders on the informations and also increase the corporate reputations through public reporting. Above? Not yet. Yes. On the review accounting and reporting principles, as mentioned, there's 5 of these: relevance, completeness, consistency, transparency, and accuracy. Next. So relevance is on like how relevant is this the emissions to your company, and completeness is to be a thorough process, account for all emission source within the inventory, and disclose any and justify any exclusions that may not be relevant to your company. And of course, to ensure consistency and transparency, consistent methodology is important to allow consistent tracking. Maybe in the future, when you have a change in baseline, you have to ensure that the methodologies that is consistent. And then this is, of course, to have a good accuracy in a systematic way to ensure there's not overestimate and also not underestimate. So you can see in the data collection part is normally in this kind of hierarchy. If there's measured data, that's definitely the best. If there's no measured data, then is there any financial data? And if none, then we will need to do a good estimate on getting the emissions. Next. Yeah. So there's a few trends in the calculation methods. Here showing the common approach and also the best practice. Common approach is generally a top-down and hybrid. So between top-down and bottom-up, which is generally a higher level. It's not into very much detail. It goes into the big overview pictures of the emissions. So the best practice is really on increasing the bottom-up practice, so that we can have more specific numbers and more accurate numbers rather than just the overview. Next. Yeah. So under the data source for supply chain emissions, we also have this chart showing that the data quality against the accessibility. Of course, supplier-specific APDs is very the best, which I will elaborate more later on in the life cycle analysis. Then moving on, we have benchmark data for average product types, and also detailed expenditure data, and also lastly, aggregated expenditure data. So the higher data quality, then the higher the confidence you have in your emissions. So on the right is an example of EPD. We can see under EPD, there's a lot more information that we can obtain as compared to just the high-level estimations. Next, please. Okay, Scope 3, identify Scope 3 activities. I think this is quite common. Gaurav has mentioned previously as well, just to reiterate. Under Scope 1 and Scope 2, under Scope 1, we have direct emissions, where emissions is from operations that are owned and controlled by the reporting company. So the company has a control on this. For example, the use of company vehicles, as mentioned by Gaurav previously. Scope 2, emissions from the generation of purchase of electricity, steam, heating and cooling. In simple sense, it's really the energy consumption from the reporting company. And again, Scope 3 is all the other emissions that's not included in Scope 1 and Scope 2, which has 15 categories here. Purchase goods and service, capital goods, energy, upstream transport, waste generation, business travel, employee commuting, and a lot of others, processing and the use of the sold products depending on which industry you're at. Okay, next. Yeah, setting the scope boundary is very important before doing the data collection and also the calculation. You need to, there's this 6 criteria for identifying the activities. It depends on the size, it depends on the influence of the emissions, the risk, and also stakeholder requirements, and whether or not these services is previously outsourced, and also what's the general sector guidance that they deem important. And moving on to the data collection, which is the very important part. As mentioned, it's an ongoing cycle. You need to prioritize the data collection efforts on the big items. So in general, there will definitely be hotspots that the emissions are higher. So you need to focus on that and to prioritize the collection efforts on that area. So the data can be selected based on the goals, significance, quality, and also the availability. And next, when you collect the data, there will be gaps. So you need to do an estimation of how you can fill the gaps, whether on creating additional surveys or doing proper estimations. And of course, lastly, is improve the data quality over time, because as the time passes, more and more companies is going to release more EPDs, have a higher confidence level on all the different emission factors. Then we can also improve our data collection and calculations. Next. Yes. On the allocate emissions, as mentioned previously, it's shown in the graph here that, for example, if a facility or system produce more than one output and you're only using one of the product, so there's like 2 different physical allocations and economic allocations. Physical allocations is divided into, for example, you use the weight, you use the quantity, and for economic allocation is really on the using the monetary value to do a ratio. Okay, lastly is setting the target. The target as mentioned, there's different targets, target type, target completion date, target level, and whether or not you want to use the offsets or credits. So the target type can, it's very common now to have a 2030 or 2050 net zero goals. And also the level, say you want to reduce compared to the baseline, 50% or 30%, that sort of thing. Next, the last two items is assurance. Assurance is optional. There's two types of assurance. First party assurance and also third party assurance. First party assurance is within the same reporting company, but in a different line of reporting where they are not involved in the data collection and calculation process. Then there's the third party organization, which is an independent assurance from a independent organization. So they process third party insurers. And for reporting, there's required information and also there's optional information in just a general view. The required information is on like scope 1, scope 2, and scope 3 emissions, and all the details on scope 3 emissions, including the categories that you're reporting, activities, and the details. And finally, when you do scope reporting, you definitely have a baseline that you're going to use to compare. And what's the rationale to choose the baseline, whether or not it's the data with the most complete one. And also, if you have if moving forward you have a big change in your company, organization, process, or maybe a big change in the organization behavior, then you have a recalculation policy and what is it. So other optional information, there's a lot. There's additional information basically further subdivided and disintegrated into very details. Those are optionals. And other additional details information such as sequestration, removal, avoided emissions, and the product performance, depending on what kind of sector again you are in. So the product performance and the product details. Next. Okay. So now I will move on to a case study to determine to form a baseline emissions. And this is in a built environment. So following the 9 process that we have just now, so the scope 3 emissions boundary can be determined through interviews and data. And then we also recognize and try to quantify which kind of emissions is very relevant to the company. And then we have an example of emission boundary here. So again, there's a lot of other categories. You really need to see which one is very relevant to you and to choose the correct one. Next. Okay. So under this one, again, the emissions can be broken down into 3 scopes: scope 1, scope 2, scope 3. Scope 1 is really on, you can do a commute survey on what company has what kind of vehicles company has. And then scope 2 is really on the annual energy consumptions, on maybe from the annual reports. And also finally scope 3, this one is the one that's making up bulk of the emissions. Can be obtained from a life cycle analysis, which I will elaborate again. Next. So the life cycle assessments includes all activities for the product from the start to the end, as mentioned as the life cycle: manufacturing, the transport, construction, operation, use, and include the end of life. So this is very important. It's mentioned in the EPD. They have all the details breakdown of this. Next, please. Yes. So this, how can we use this in the industry? With the EPD, we can measure the existing performance and monitor improvements, because since it's a life cycle analysis, we can pinpoint the process where if you have any innovative process, what kind of improvement you are making, and to compare between different materials on the APT performance. Yeah, next.
Maybe just on that part, like I just wanted to understand from the audience that how many of you are in this business where you are creating or manufacturing products? Can I just have or everyone is doing business and trading? Why I'm asking is this term EPD is very commonly used in Western nations, and it's soon being adopted in lot of green certifications and products. So it's a very detailed calculation of a product life cycle, starting from raw material extraction up to the end of life. So it's kind of you can say it's a full life, how much emissions that product can have in an entire life. And it's a very easy, once you have an EPD, it becomes very easy to just multiply by how much kilograms or tons of that product you are using.
Okay, yeah, thanks. Moving on, I'll go into the calculating of carbon emissions, just to give an example on how do we calculate and quantify this kind of emissions quantitatively. So I have 3 examples here. basically the general is to get the carbon emission is get from the activity multiplied by the emissions factor, where the emissions factor is the one that's very important that we need to continuously improve. For example, for material usage, we have the material emissions factor derived from EPD again. Then carbon emission factor for electricity usage, this one will be depending on our national grid emission factor. So when our national grid have a higher portion of renewable energy, then this will definitely bring down the grid emission factor, and of course can reduce or say scope 2, because scope 2 is also from the electricity usage. So you can see other companies, for example, Singapore, they have around 0.4 for their grid emission factor, and we have around 0.78 now. Okay, lastly, for transportation is on the emission factor is normally given in a kilogram CO2 per km, depends on the type of vehicle and also the fuel type. So we can take the total distance and multiply by these factors to get the carbon emission. So you can see I put 15 kilometers roughly from my office to these locations. I've already emitted 3.24 kg of CO2. Next. Yeah. So this, moving on to another interesting item that we can calculate is on the carbon intensity. So in this case, in the built environment, we calculated the carbon intensity per GFA. So per GFA and also per capita. So we can see there's two levels to play, whether or not we increase, like for example, if you build a house for very little people to stay, or you build a house with a higher density, that will definitely reduce the intensity per capita. So it's just a way to look at things in terms of GFA and also in terms of per capita. Next. Yeah. Next, I'll pass on to my colleague to talk about how can we reduce the emissions with all the calculations and the baseline that we established. What's the way to move forward? Thank you.
Yeah, so I think you may have had some understanding on how do you calculate emissions. So from the previous few slides, you have seen that there are ways, and there is one very important term is carbon emission factor, and that is something which varies from products to products, and also varying from countries to countries, and also varies from companies to companies, how you are producing it. So for example, if you talk about one product and that is emitting, so the carbon emission factor is generally in terms of how many kgs of CO2 was released in order to produce 1 unit or 1 kg of that product. If let's say you are creating more carbon, definitely your emission factor will be more, and if I as a company is purchasing those products, I will have a higher emission scope 3, in which if I try to reduce it, and that has a very direct implication on this whole supply chain, and that will start a cycle where the product manufacturer will start looking at ways, how do I reduce my 0.7 to 0.4 or even lower, because then I have a lower carbon emission and I will have a higher demand, because companies and those who have committed net zero are looking for those products. So that's the whole cycle and whole life cycle of the products or services in this whole industry is working on. Next, please. Yeah, so I will break down this in terms of an organization, and then I also have one case study of a building, and then we'll end this with question and answers. So for capital goods, definitely there are ways you can reduce your emission, is how you can have alternative materials with lower carbon footprint. For example, we have concrete and timber, and so let's say a company A is producing 1 kilograms for 1 meter cube of concrete. That's not good. You can start looking for sources or suppliers who are producing less than that. Or you can even look for alternatives of concrete. Can I make it in timber? And there are buildings in this region which are now slowly picking up. Low-rise buildings can be made in timber, and timbers they have much lower emissions. Generally, they have even negative emission because they are absorbing carbon dioxide from atmosphere. Alternative methods of using the products, for example, industrialized systems that can be that can have much emissions as compared to non-industrialized. Working with supply chain, you work with your suppliers and then kind of bringing everyone together to push this decarbonization agenda. Upstream transportation, source locally. That's the best solution because you are avoiding transportation emissions. Whichever is available locally, you source it, and generally it will also save you cost. Optimize logistics and utilize low emission transport options. Instead of diesel, you can use electric vehicles. And so, next. Waste generated in operation. This is also is one of the higher emissions in those organizations who are into manufacturing, and a lot of waste is generated. And try how you can use a circular principle in which whatever waste is generated you can bring back into your cycle. If not, then you can try and produce something else. Increase awareness in waste and transportation schedule. Sometimes industries don't focus more on waste, so you can increase awareness, education around that. And then again, last one is the business travel. So encourage remote work. Maybe reduce business travels if possible, or there are ways you can again like source carpooling. For example, we had choice to take 2 cars, but we decided to just choose 1 car, so we reduce our emissions half at the same time. And adopt travel policies which promote emission reduction. So there are for example, if you had to travel, business travel, there are companies who are now started disclosing their carbon factor. So now one thing I have noticed is if you start looking at the flight booking, they show what is the carbon emission of those flights. So you can have a choice that, okay, I should choose this or I should choose that. Next. This one is a roadmap we have done for a building, and why? Because again, in one of the slides earlier, I mentioned that building consume around 70% of emissions from their operations itself. That operation is mainly coming from building energy use. So, and what we have done here is we have, and again, is everything you do is a cost intensive exercise. You cannot do everything today and then wait for it because it's an ongoing process again. So there could be 3 actions you can plan, immediate actions in which you can reduce it, and that generally those actions should have less capital and have an immediate savings. So identify those instead of going with the big options and exhaust your capital. Then there could, for example, the immediate actions could be just change your settings. If this room is too cold and everyone is wearing jacket, just increase the temperature and it will give you immediate savings, no extra cost involved. Changing lights to LED lights or even more efficient lights. Insulating the building so that whatever cooling we are producing is not thrown outside. Then the major refurbishment could be planned ahead in 5 or 7 years of time, and then you can think of what could be the possible solutions I should bring in coming 5 years, so that, and these emissions generally will have much higher savings because you are looking at your equipment replacement, and that's also a time where your equipment are going to die, and that can be planned based on that timeline. And then the additional last could be engaging your tenants, because tenants are the one who have least interest in your decarbonization journey. So include them. Don't just focus on your common areas or your own areas. It's an inclusive exercise. Even sometimes there is a common term ongoing in the built environment is called a green lease. Offer them a green lease in which there are incentives for both parties, and both parties are gaining because both parties are working for reduced emissions. And also the last one could be green power purchase. For example, if you don't have a big area or if you don't have capital to invest in solar panels, you can purchase in terms of RECs, renewable energy credits, or green power purchase or carbon offsets to further bring your emissions down or eventually to zero. Next. Sorry? Yep. So that decline is based on the assumption that the grid is decarbonizing, because even, yeah, that's a very good question. So for example, we just take one example here is, let's say in by 2050, Malaysian grid is decarbonized. So currently the number you have seen 0.78 kilograms per kilowatt hours. So in order to generate 1 kilowatt hour of energy, we are generating around 0.7 kilograms. moving forward, that 0.7 will further go down to 0 or 0.1. So that's the curve. So even if you do nothing, your building will still decarbonize, but there may be a risk of prices, electricity prices going up, or there could be a carbon tax implied on you because you are still producing and you are not doing anything to your building, or you are not doing much to reduce your emissions. Yeah, next. I think that's my last slide. Yeah. Now we are open for questions. If you have any questions or any discussions. Yep.
Yeah, I got a question about calculating scope 3. Yeah? For example, if we buy 2 products from a manufacturer that produce 10 products, they use electricity bidding for all their production, right? So how do I calculate the carbon for these 2 products?
The answer would be EPDs. If you go back to few slides back. So you're right. Okay. For example, right, I have a screenshot of a, go back. I think few slides back. Back. Yeah. One more. Back. One more. Okay. More. I think it was few slides back. No. Back. Okay. There was one slide where we were talking about EPDs is called Environmental Product Declaration. So that company, that manufacturer who is producing these 2-3 types, he will have a standardized values for each products. So generally how it works is he will calculate in order to produce one piece, let's say a glass window. So in order to produce 1 square meter of glass window, he will declare that he is using 500 grams of CO2. So that will become a product description of that window. Let's say now the same company is making a big door, aluminum door, there is no glass in it. So he will disclose the carbon emission factor for that aluminum window. And when it is supplied to you, you can have these emission factors. And let's say you are purchasing 100 square meter of one glass window and 20 square meters of that door. And it's just a multiplication of factor, and then you can get your emissions.
Okay, so we get a number from their numbers. We
Yes.
get their numbers
Yes.
into our calculation.
Yes, exactly. So the slide where I showed that there's a cement manufacturer company who is trying to reduce by 50%. So which means that he would have done his calculation, and then he saw that I have a potential to further reduce it by 50%. So that's where the measurement is the most important one. If you start measuring your emissions, you can straight away see that how much he could have commit, I will do 100%, but he thought that, oh no, maybe that's the maximum I can do, because you still have to burn, you still have to operate your furnace. Maybe you can choose electrification for your furnace instead of burning petrol or burning those heavy carbon emission fuels. So yeah, so that's how you can, and that's where in one of my slides I had shown that your supply and your sourcing should be responsible, and you start asking for it. And now there are many companies, for example, even some companies, they just take general values, but they have a very good practice and their values are much lower than the general values. So once you start calculating, then you can know that, oh, okay, actually I'm not that bad, I'm sustainable, but then I can have a potential to further reduce it by 10% or 30% down the line, because now I see. And in one of the slides there was a calculation in which we showed that the energy consumption was very less, but the main contributor for energy consumption of that factory was lighting and compressor. So if he cannot change the compressor, at least he can change lighting. So he has a potential of further reducing that maybe 5% or 10%, and that's how you can start optimizing your products. That will be your scope 3, and then that's how you decide that how much reduction I can have.
Okay, if I may, just one more question. Thank you. You know, whenever companies set net zero by 2050, isn't it is only scope 1 and 2? Because if scope 3 is included, they have very little control over scope 3. Almost impossible, I suppose, to get net zero based on scope 3. So when they say net zero 2050, do they really mean all the 3 scopes or just scope 1 and 2?
For now, what I have seen, most of these companies are mainly focusing on scope 1 and 2, and if you have, in one of the earlier slides I shared that scope 1 and 2 is under our direct control, because we can control easily, because that's the emission we are having. But now we are seeing scope 3 emissions also included in those net zero commitments. Why? Because you can again choose a supplier or a company, and his goal is also net zero. So it's the whole ecosystem which is designed towards that net zero framework. So for example, if I am purchasing a product, let's say this chair, and this chair manufacturer has says, oh, I want to be net zero by 2050. So which means that the chair which I'm buying already has a zero carbon footprint, and that chair is my scope 3. So it's still a big open concept because it has so many things, open boundary, but we are seeing scope 3 being included in some of the disclosures plus commitments from organizations as well.
Slightly philosophical question. If the company shut shop, their net carbon will become zero. So how do you kind of sort of balance value creation with sort of what's your net carbon output? Because otherwise, everyone should shut their businesses.
Yep. So yes, definitely. So we do the in buildings we say that the best building is the one which is not created, right? So, but that's not we are working. We still have to make profit, and organizations still look for profits. So that's I believe that that whole ecosystem of whichever product or supplier or industry you are working with, that should be all should work together to meet that target, not just once. For example, if we decide that I want to be zero, and then not everyone is aligned towards that, then it will be very difficult for organizations and companies to be net zero.
I have two questions. One is, my name is Chin.
Hi.
There are 15 categories in Scope 3, so they are divided into two main upstream and downstream, how they are mainly differentiated. Just the clarity will help me to understand a bit more. Question 2, Singapore has come up with a carbon calculator for its building, I think government building. Maybe you can just highlight briefly its features or something that's very striking. Yeah, thanks.
I think upstream and downstream one is very like based on its term itself. Like once is you are doing upstream calculations, which is more in control, and the downstream is like you are monitoring your tenants. On the second one is you're asking about is it that the online calculator is released? Yeah, we are also using that, and we were one of the early testers of that product as well when it was in an Excel based form. So that is actually a very good initiative. It's basically, it helps you and it is mainly focused on buildings, as a building owner or developer, how much emissions you can have if you choose certain materials. And then again, it has a emission factor assigned for certain materials, starting from the big materials, like what Hanyu has mentioned, that first focus on all the big ticket items. So what it does is it has following the same principle of quantity multiplied by carbon factor will give you carbon emissions. It has concrete, steel, glass, plasterboard, all those important materials which are being used in the buildings, and it has an emission factor assigned. It also has a transportation distance, and all the countries listed. For example, if you are Singapore purchases most of its products from outside, right? They are not producing much of building products. So you can choose distances, and then it has, again, it's a top-down approach, because it's not a detail. You are not doing that calculation. So you just choose Malaysia, and it just assumes that it's at around 1,000 or that 1,500 kilometers. So it is not exactly choosing that. JB is also Malaysia, which is very close and very far from, like top north is also Malaysia. So it is still using generalized numbers, but at least it is giving you a very good starting of how much emissions you can have, and you can create options. Option 1 is if I use this. Option 2, if I use this, and you can directly see that how much savings or how much carbon reduction you can have just by choosing and clicking, dropping down few options. That gives a very good start, even if you have not consulted your architect or designers, that, oh, I have a list of materials, and I think that these materials will give me a reduced emission or a reduced target. That will then be converted into kilograms carbon per square meters, and that is compared against a benchmark, how good or bad you are against a common commercial buildings in Singapore, or commercial or residential or industrial building in Singapore. Okay, I think I'm not an energy expert, but my guess is that it's how the energy is produced. I think most of the energy in Singapore is produced by gas, natural gas, and that has a lower emission factor. I'm not sure about how Malaysia energy is could be, because I see that emission factor of Malaysia and India is almost similar. I know India uses a lot of coal for energy production. So I suspect it's a mix of coal and natural gas. That's why it's somewhere between, for India, it's around 0.8 something. So it's almost there. So I believe that's the main reason. There's also a huge potential in Malaysia because it has a big land mass and also to capture more of natural resources in terms of solar and wind. And maybe moving forward, we can see a dip in that number. Yes.
I just want to circle back to the gentleman's question earlier about net zero and scope 1 and scope 2. So, net zero, from my understanding, it means not emitting at all, right? So, can say realistically it's an ideal, right? It's not, can you actually be net zero?
It depends. For example, for buildings, yes, you can be net zero if you have a footprint. And we have seen few examples already. I think there is one building I recently saw in Malaysia, it's a university in Malaysia. It's a net zero building. It has a big canopy. You may have seen in news in Singapore there is one net zero building. But those are all focusing on net zero energy. If you think about carbon, it's a difficult, because in order to create something you have to have some sorts of emissions, but then those can be reduced, the first one. And then if you have, I had that one slide in which there are 3 ways of meeting that net zero. First is you reduce it so that you can offset it, or you can even have a positive like you can remove carbon from the environment. So there are technologies like carbon capture, so those can offset that.
That's carbon neutrality, right? There is a difference between being carbon neutral, where you're balancing out your emissions, and net zero. So when companies make the net zero declaration by 2050, let's say, so are they actually really saying, okay, by 2050, I'm not going to emit any carbon at all? In which case, there should be no scope 1 and scope 2 to calculate. Sorry, maybe I'm splitting hairs here, but
No, it's
just
fine,
want to
yeah.
get the definitions correctly, because we're throwing around words like carbon neutrality and net zero, and I noticed even throughout the course of this summit so far, I've seen people use it interchangeably, but based on my own understanding, at least in my own work, I understand net zero to be very different by definition.
Yes, net zero is absolutely what it means. It's you don't generate anything. But what these companies are targeting, if you see, is most just put net zero emissions, which means that whatever emissions they are generating, they will be offsetting by either renewable, and it's not just one time. It's on a basis of 1 year. So whatever the measurement we were showing you in terms of carbon emissions, it's not based on 1 day or one instance of time. It is generally calculated for 1 whole year, which means whatever emissions you are creating in 1 year, you will be offsetting or removing that in 1 year. So that's what they mean. It's mostly yes, neutral. There are so many definitions, and every region has their own definitions. You're right. Yes, you're right. Yep. Offset it, yeah. Yep, yes, you're right. And that is still being calculated in CO2 form with a small e, which is equivalent. Yeah, and that is considering all those gases. But yes, there is a can say how organizations are targeting. They mean the same. They are not meaning that I shut down business, which one gentleman pointed. They still mean that their operations are continued, but not business as usual. They are taking means to reduce it and then further offset it or make it zero or even sometimes positive. For example, one of the companies, the big data company, they have committed that whatever energy they will use in whole of their operation will come from renewable sources, and they have done that. Sometimes they do by installing on their sites or installing on big landmass. Sometimes they also do by purchasing renewable credits. So it's a mix of how they do their operations. Yep, please.
I have to agree with the gentleman. There actually is a difference between carbon neutrality and net zero. And I think I would urge us to look a little more into it so that we can also iron out the definitions.
Yes, I think, yeah, you can go by textbooks, but the main intent of this is how I personally think is it's not just about zero and even positive or 90% or 50%. It's about how we as an industry taking effort, because to be honest, we have not even started taking steps and we are talking about zero. There are companies who doesn't even know that how their emissions are and they are talking net zero. So I think the first and foremost step is sit back, do your calculations, assess where we as an organization, we as a company, or we as a nation is, and then we can start looking into possibilities how you can be net zero or even like the last case study I showed it was not net zero today. We had planned short-term, medium, and long-term goals, and that's how you can achieve that task. So that's more important. Definitely, there are definitions which have been like net zero, absolute zero, neutral. The end goal is the same: is decarbonize it. There should not be any harm to the environment. Curb the temperature of 1.5 degrees even below. Yeah. I think good. I'm happy that at the end we had a lot of engagement. It's very good. I hope you enjoyed the session. If you have anything, you can contact me or you can reach out to us, or I'll be available after this session as well, so we can discuss more. Thank you everyone for your time and